Hello and welcome everyone. My name is Eric G. I'm a senior solutions architect at F5. Today, I will be discussing how to efficiently scale multi-cluster OpenShift deployments with F5 Container Ingress Service. Before diving into the details, I want to touch base with why behind distributing the traffic across multiple OpenShift clusters. The first reason is flexibility in deployments. So multi-cluster environments enables strategies like blue-green deployment, A/B testing. Those not only allow for reduced downtime during the updates, but also make it easier to try new features. And also high availability is not only about downtime. By spanning the application across multiple OpenShift clusters, you can achieve geographic distribution, potentially serving the users from multiple data centers. And also load balancing. With ratio load balancing, traffic can be smartly and efficiently distributed across multiple clusters based on the resource availability. As your user base grows, you also need to expand and upgrade your clusters. By running multiple clusters, you can perform seamlessly migration upgrade of workload without any downtime to ensure the best possible user experience. This is where the BIG-IP Container Ingress Service, or CIS for short, comes to play. Let's take a look to see how a BIG-IP Container Ingress Service can help tackle the multi-cluster challenge. So as you can see from this diagram, we have two OpenShift clusters. Essentially, we can have multiple OpenShift clusters. We installed CIS in two of the many OpenShift clusters. First, the CIS can retrieve the kube configuration from the config map for all the external clusters. Then, it will use that kube config to subscribe to informal events for all the other external clusters. And also, for high availability between those two CIS, primary and secondary CIS, they can have heartbeat check. But at one time, only one CIS will post the BIG-IP change through the AL3 declaration. In this way, we can minimize the risk of conflicts. Now, let's take a look at how we can put this into action. In this demo, I will demonstrate how to use F5 BIG-IP CIS in a multi-cluster OpenShift environment. So we will start with configuring the multi-cluster BIG-IP CIS. Then we will distribute the traffic across two clusters. Next, we will explore the ratio load balancing the traffic across two different clusters based on the ratio. And finally, we will see how we can seamlessly migrate the app from one cluster to another. Without further ado, let's dive into the demo. First, we're navigating two OpenShift clusters. Cluster 1 running 412 and cluster 2 running 413. Let's kick things off by jumping to the command line. Recalling our setup, we've got two clusters with 6 nodes each. Starting from OpenShift 412, default CNI is OpenShift OVN Kubernetes. Let's highlight the OpenShift OVN Kubernetes setting. So here we are looking at one of the OpenShift nodes. So we are seeing that OVN Kubernetes configuration and also the port subnet for this node. So moving forward, one of the prerequisites for multi-cluster CIS deployment is to ensure we have a unique port network for each OpenShift cluster using OVN Kubernetes. In this screen, we're seeing that different port subnets, the CIDR 10.128 for the cluster 1 and 10.148 for the cluster 2. Next in line, we can go ahead to deploy the big IP CIS. Here we are making the CNI as OVN Kubernetes and also enabling the static route mode as true for the dynamic route population. Let's push forward and deploy CIS. Transition to the big IP UI. It's evident that the route dynamically finding their way to the routing table. As you can see that every subnet route direct toward the OpenShift node IP. As you can recall that we have 6 nodes for each cluster, meaning that we have 12 subnets. Shifting focus to Kaffe app, we deployed in the Kaffe 1 namespace. This app consists of 3 microservices. These services are mirrored across 2 clusters, as you can see here. Our next step involves the global config map, showcasing a sample multi-cluster config setup. With the standalone CIS, so cluster 1 is the primary cluster, then cluster 2 operates as a remote cluster. So we are using the extended spec config map to define a common config for route group. That means it will apply to all group routes. Switching gears, let's introduce the route resource with a MultiCluster annotation. We are seeing that this is a typical route configuration with a added MultiCluster annotation to expose the apps in different OpenShift clusters. Heading back to the big IP, we are checking the configuration posted by the CIS. We are seeing that virtual server is created with a single IP hosting the app across multiple clusters. Policy and rules for hosted-based routing are in place. We're looking at the pool displaying 6 members, 3 from cluster 1 and equal number from cluster 2. Now it's time to take the Kaffe app for the spin. It's up and running. Now I'm switching to A/B tool to mimic real-world traffic. By the way, A/B tool is a benchmarking tool for HTTP server. Let's go ahead to fire up 1,000 requests. Swinging back to big IP, the stats confirm that our requests have been evenly distributed among 6 pods across those 2 clusters. Coming up next, let's explore ratio load balancing. So we will go ahead and update the global config map. Here we are flipping the mode type to ratio. We're also setting the ratio value for both clusters with the spotlight on 1:4 traffic distribution. Go back to big IP. Let's wipe out the stats. And also use the A/B tool to send another 1,000 requests. Checking the big IP stats is clear. The traffic ratio now between cluster 1 and cluster 2 follows approximately to our settings 1 to 4. So finally, let's have a spotlight of app migration. As you know that we have numerous ways of doing the app migration. For simplicity, I just scale down Coffee service in cluster 1. Back to the big IP, it's evident that the app now calls the cluster 2 as a home. As you can see here, all the traffic is directed to cluster 2. With that, I wrap up our demo for OpenShift MultiCluster with Big IP CIS. In today's session, we demonstrated how to scale multi-cluster OpenShift application using F5 Big IP CIS. Let's revisit what we learned. So F5 Big IP CIS offers a seamless traffic management across multiple OpenShift clusters. It also provides granular control to do the ratio load balancing across multiple clusters. Also, it provides the easy migration of the applications across multiple clusters. And most importantly, this is a must-have feature for all modern multi-cluster deployment for OpenShift. All right, so we covered a lot today. We believe we have some time for questions. Let's see, we already have a couple of questions. Let's dive into them. The first question is, how is multi-cluster CIS different from the GSLB solution? That's an excellent question. First of all, multi-cluster CIS and GSLB appears very similar, but I think they are addressing different challenges. The CIS is more tailored to optimize the traffic across OpenShift clusters. So it's about a way to manage traffic, allow us to expose applications from multiple clusters through a single public IP. And GSLB, on the other hand, is more about geographic traffic distribution and ensuring users can connect it to the nearest location. It also requires the DNS. On the other hand, CIS is we don't have to modify the DNS. So the second question is, can you explain how the CIS failover works? Sure, absolutely. So the failover process between the primary and secondary CIS. So basically, as mentioned in the presentation, there are regular heartbeats between the primary and secondary CIS. So every several seconds, the secondary instance will check the health of the primary instance. If it detects any failure, the secondary CIS instance will take over and act as the primary. So in this way, we can ensure that consistent traffic management and also all the applications will stay accessible. Great questions. Thank you for bringing them up. If you have more questions, please don't hesitate to reach out to us. In closing, I'd like to thank you for joining today's session. I hope you find the information valuable. I look forward to seeing you in the future webinars. If you have any question, please feel free to reach out. Thank you and have a great day.